This is Andy coming to you from the perspective of a shameless novice. And what I mean is I'm just trying to solidify what I learned, uh, but also kind of take you along for the journey because it's fun to learn these new things. And so I don't know if this will turn into a channel or a vlog or a log for future self, but whatever it is, welcome. This project in particular, this is a fun one. It's my first Go project, and what I did here is it's an authentication application. That's all it is. I'm accepting a username and a password from a front end and authenticating against a SQLite database, also in the code, and then returning whether or not the user is authenticated. So first things first, every executable package in Go needs to have a package called main. And the way that the entry point for a Go file is the function main, which takes no survivors, no arguments, and returns nothing. So that's main. This is the entry point, and from here I can call all the other functions needed. Then I have my imports. We have standard library imports, I think. Open source, which in order to use them, I need to run go in the terminal, go get and the name of the package that I want to install. And then also my local modules. And so actually modules, this little dinky thing right here probably took the most time out of this entire project. And the reason is because there's a lot of cool capabilities here. First is it's the substitute. So Go mod is the substitute, or the maybe even improvement of a Python virtual environment. Of the purpose of a virtual environment is to separate dependencies, keep them isolated from other environments, including your main environment on your operating system. So when I run go mod init and then the name of my module, which I named this right here, it's going to start recording every module that I import to run my code. And so here's and then when I run go mod tidy, it's going to check all of the imports that I have and make sure that they're here. And then this go.sum file is created at I think compilation. It's the first time that I run go run, so I think compilation. And what it's doing is it's recording the name of the module with specific hashes and versions of dependencies. So that's why I say it's like a virtual environment, because it's recording specific versions, like in case that updates in the future and my code relies on this version. So it's recording versions and also dependencies. So that's pretty cool. Then the name of the module. A couple best practices here. First is to make it distinct so that if there are any open source packages that are published, we want to make sure that this one doesn't have the same name as that one. So I named it after my GitHub username.com/API authentication. This is another best practice, which is to name the module after the folder in which it resides. So you'll see this in other locations as well. Okay, and going back to main. Okay, so don't actually think I need this here anymore. Let's see. So I'm doing two main things. And they're both using this database. I would say it's like a class. This is typically where I keep a class, which is a thing that does specific things. In this case, it would have been a database class that does database specific things, like create table or create user in that table, that kind of stuff. But there are no classes in Go. Instead, there are modules. And modules are essentially, like, this is performing the same function as what I would do with a class. There are structs. And so here in this module, I need to start thinking of files in Go as modules. They're modules, not files. This module, you'll see, is in the database package, and that is how in main.go we pull it in. Is we need to use the absolute path. None of this relative stuff like that. Absolute path. down to the name of the package. So package name is database, and then I can call functions. But notice this is a capitalized function, capital case, and it has to be capitalized in order to be publicly accessible. Otherwise, like these lowercase guys, camel case guys, they are only privately acceptable, or in other words, only accessible inside of this database.go file. So in order to make it publicly accessible by another file, main.go, has to be capital case. And so you'll see this is actually a pretty cool, nifty little function that I came up with. We accept a username and a password, and then query type. The reason that I accept query type is because we need to be able to create a user or read a user, validate a user, depending on, so kind of following CRUD verbs, depending on what we want to do from main. And the reason that I set it up like this is because either way, we need to initialize my database. So we initialize database by using this package, package, and we initialize the database. It's going to be a SQLite database called user.db, and I have this other raise error function that's inside of helpers. It's just checking if there's an error, and then once that's done, I'm going to create table. And create table, another lowercase or camel case function, is only creating table if it does not yet exist. And so that's kind of the beauty of this, is that I'm always going to be doing these two things. Like worst case scenario, just to take precautions, I'm going to be creating a table if it doesn't exist. So if I pass create, I'm going to create user, and I'm going to accept a username and a password as parameters. So here's my arguments: username, password, and the way that I do that. So Go is statically typed, although it has type inference. I don't know why I said it like that. Inference. And the way that we infer type is by saying new user, which is of type user. Actually, so I guess I could do this another way. So I'm instantiating a struct right now. So it's of type user. And so this is another way of doing that same thing without inferring. So I could do this. And my struct is going to accept a username, which in this case, the value is the username passed and password. And so I'm creating user, and then that's going to call save user, which is my actual SQL query. And so I'm going to insert user and this database /SQL package, where did I initialize this? Initialized it right here. And so that has a function, function, execute, and I'm going to insert the user. I'm kind of getting lengthy here, so I feel like I need to speed it up. But we're going to insert the user, and another cool thing about Go is that I'm going to declare which types are going to be returned by this function. So string and error. In this case, because an error was not raised, I'm going to return nil, which, this is another cool thing. If I were to, let's see, so error is being created here, it's being inferred. Another way of doing this is I could say var error, and it's going to be of type error, and that's all I have to do. I don't need to set it to anything, because by default it's going to be set to its null value, which for errors is nil, like this guy up here. For strings, it would be the empty string. For integers, it would be 0. So we have default initializations. So that's kind of cool. And let's see. So returning user message and nil, my user message is a string, and I'm going to pass that up to user message here, and then ultimately return it in create user message. Let's see, got lost. User message, create user. So here is my message, and then I'm going to return that with a value of true. You can see that I'm returning a bool, And so right here, I just needed to return it. But the reason that I'm returning it here is because I'm checking whether or not a user is validated. And if they aren't, then I'm going to be returning false. And there are two cases when they aren't. Either the user wasn't found. I'm selecting password from users where username equals the username provided. If the username was not found, so nothing was returned by this query, then I'm going to return false. User not found. If the user was found, but the password provided by the post, the form, does not match this password, which I'm scanning into stored password. So if those don't match, then I'm going to return the message invalid credentials, like user was found, but invalid credentials, and not validated. And then lastly, if neither of those things are true, I also could have done an else, but that's kind of redundant. I'm saying return login successful, and it was validated. Success true. So we're going back to main.go. I'm using the Gin framework, which is like Mux. This is going to enable me to create a router for my REST API. So I create a REST API that is going to accept a post method. I tried a get method, couldn't get it to work, so I'm serving that up in another way. But a post method at least, so that's why I say it's a simple API, but at least it is accepting one verb. And so my router, my Gin router, when I post, I'm binding my /login URL to this context. And I think of context as, there's a library in Python called TastyPy, if anybody's ever used that. TastyPy, the way that it handles API requests is that there's a lot to an API request. There's the URL where the request was made, there's the headers, there's a request body, if there is one, and also cookies, just session variables. And so all of those things are wrapped into what's called a bundle in TastyPy. And I think of this the same way as a bundle. It's a context, which is everything there is to know about a request. And so what do I want to know about this context, this request? I want to know what was the username that was posted, and I want to know what the password was. And I'm going to put those into these inferred type variables, username and password. Then I'm going to check if that username and password are authenticated. And the way that I do that is, as I just explained, I'm passing it to database.controller, capital C, with the query type of read, and I'm going to get back a bool, this bool. So this right here is evaluating to true. If is valid user, that's true. Then I'm going to say status is okay, 200, and my message is the message that was passed back. If not, then status is not okay. This is an unauthorized 401, and I'm going to pass back whatever message I got from here. Okay, so let's, and lastly, I'm going to serve this up on localhost port 8080. I'm also, you're going to be confused because I am serving, I'm serving also on port 5500, which I'm doing with VS Code's live server. So if we go to index.html, I'm serving on port 5500. So that's here. Username, so person 5, this is my SQLite database. DB browser for SQLite is a nice little tool. I could also check this in Go, but here's a nice little GUI for SQLite. So I'm selecting that from my users table, which I created in database.go. And I also, in main.go, if this was just a funky way of commenting this out. If I were to actually comment this out, the problem with that is now these guys are not being used. Database should be being used, but if I were to comment these out, database still should be used, but oh no, it's not even used here. Don't even need that here. That's okay. But you see what happened is so I was using this format library, and because I'm not using it anymore, and also because Go optimizes at compilation, it's going to just get rid of any packages that I'm not using. So when I save this, gone. So I didn't want that to happen. mostly because some previous stuff that I was doing with this. I guess I don't care so much now, but anyway. So that's, if you're wondering why I have this and that's never going to be true, that's why this is here. So this is how I would create these oops, where'd it go? These people, these records. And so let's, without further ado, you're probably like, get to it. Without further ado, let's do this. So person 5, and person 5 has the password. Secret password, person 5. Ooh. Oh, because I'm not serving. Let's run main.go. Yeah, okay, sweet. So listening and serving on port 8080. So that was bad. One thing that I want to check here is that this is in fact required. So that's kind of nice. Also, kids, don't try this at home. And the reason I say that is because we are not doing any hashing or like any sort of lengthy authorization like we should be. I'm just storing these. That's not the purpose of this little tutorial that I'm going through. So I'm just storing actual string values of passwords, which is a big no-no. Don't do that. So first I'm going to check. So I just typed in a bunch of nonsense. So person 5 does exist. That password does not. So invalid credentials, just as we expect. What if that person does not exist? So what do we get? User not found, just as expected. What if I do person 5 and secret password 5? Try that. Login successful. Very nice. Okay, cool. So everything's working just as expected, except for this. I couldn't get to work. That's for a future time. But in the meantime, that's everything that I have for today. Future steps are I want to try Mux instead of Gin. I also want to try a different front end rather than just this dinky HTML. So more to come, but that was a lot of fun.